Hello viewers, I am Kausalya. Today we are going to solve a problem in two methods, right? And here the problem is two batteries A and B are connected in parallel and a load of 10 ohm is connected across their terminals. So here what it means, we are having two batteries. What do you mean by batteries here? We are having two voltage sources, right? And the voltage sources are A and B and they are connected in parallel, right? That is, you see here I'm having A, right, and here I am having B. They are voltage sources, right? They are connected in parallel and a load of 10 ohm is connected across their terminals. That is, what do you mean by across here? Again the load is also connected in parallel, right? So here again a 10 ohm resistor is connected in parallel, right? This is the simplified form of the circuit here. The next thing is A has an EMF of 12 volt and internal resistance of 2 ohm. Right. It has a voltage source, that is A has a voltage of 12 volt and it has internal resistance of 2 ohm. Right. Internal resistance is something which will be present in all the voltage sources. Right. And B has an EMF of 8 volt and internal resistance of again 1 ohm. Use Kirchoff's laws to determine the values and directions of currents in each of the batteries and in the external resistance. So here we have to calculate the currents. Okay, we have to calculate the current values, either 5 amps or 6 amps, something like that. Then apart from that, we have to calculate the directions. Okay, current flows from which part to which part. And also we need to calculate the value of current that flows in this 10 ohm resistance, right? Also determine the potential across the load. So here the load is 10 ohm resistance. What do you mean by potential? Potential is nothing but voltage across the load or voltage drop across the load. Okay, anything is fine. Now we have to draw this diagram. Okay, here no diagram is given for this problem. So here I had drawn the simplified circuit. Now we are going to draw the diagram in detail because you see A has 12 volt and resistance of 2 ohms and B has 8 volt and resistance of 1 ohms. So we have to draw accordingly. So now you see this is your voltage source A and this is your voltage source B and these two sources are connected in parallel, right? Then we are having a load of 10 ohm resistance that is again connected in parallel with the circuit, right? So the same thing, okay, the diagram here I had drawn, right? The same thing I have drawn here with the respective values, right? Now we are going to calculate the value of current that flows through, that flows through this A battery, this B battery as well as through this load, right? So here we have to use, again first we are going to solve this by using Cramer's rule, right? First we are going to frame matrices by Ohm's law. So what is Ohm's law? Ohm's law is nothing but V is equal to I into R, right? And before to proceed, you see the main thing to be noted is here I had assumed the direction of current by myself, right? So I assumed that the current flowing through this closed path as I1 and this closed path as I2. Right, since here we are having two loops, two closed path. This is your first closed path and this is your second closed path, right? So here I have assumed the direction of current by myself. Again I am repeating, no need that the direction of current should be always like this. It's up to you, right? Even you can take the direction like this, right? You can take the direction in clockwise. I had taken in anti-clockwise. It's up to you. You can take direction as you wish. The thing is you can take one in clockwise and another in anti-clockwise also, right? Everything holds good. Okay, it won't create any mistake. So here just I had taken the direction like this, right? Now we are going to frame expressions. So here what is mean by V? The voltage source available in first loop and the second loop, that is your V matrix. So when you consider, let this be your loop 1. So here flows the current I1 and this is your loop 2 and here current I2, right? Now you see That is, current flows in this way. It flows here, it flows here, it again come back and it flows like this. Right. So again from the battery terminal, you see this is your minus and this is your plus, and again this is your minus and this is your plus. Right. So initially you see when you observe the current, it flows from minus to plus, that is from lower potential to higher potential. Therefore we can take this 12 volt as plus 12 volt. Again when you come by this way, the current flows from plus to minus, right? That is from higher to lower potential. Therefore here this 8 volt is considered as minus 8 volt, right? So 12 minus 8, that is the voltage sources in your first loop. Am I making clear here? So that is the thing, right? First thing is we are calculating only V. So in the first loop, we are having two voltage sources. Depending upon the direction of the current, I had allotted plus to one voltage source and minus to another voltage source, right? And the next thing is now consider your loop 2, right? In loop 2, what is your current direction here? You see, current flows like this, that is in this way. Right. So the current flows from minus to plus. Therefore, here we are taking the voltage as plus 8. Right. And as usual, the current flowing through this first loop is I1 and the second loop is I2. And now we are going to frame the resistance matrix here. Right. So here, as usual, the diagonal elements occupy the sum of resistances present in the loop. Right. So in the first loop, what is the sum of resistances? We are having 2 ohm and 1 ohm. So 2 plus 1 gives 3. Right. So 3 here. Again, look at the second loop. This is your second loop. Right. And second loop has two resistors. One is 1 and another one is 10. Therefore, 1 plus 10 gives you 11 ohms. Right. Now, the second thing is, again you can write like this. It will make you quite easier. That you see 1, 1, 3 and this 2 to 11. That is the diagonal elements will give the sum of resistances present in that loop. Right. Now, check whether any resistor is common between your loop 1 and loop 2. So, this is your loop 1 and this is your loop 2. So, here this 1 ohm is common. Right. So, again now consider the direction. So, I1 flows through this 1 ohm like this, right? Because you see it flows like this in this way. Whereas I2 flows in the opposite direction. So, in this case, we have to include a minus sign, right? Therefore, minus 1 and minus 1 here. Am I making sense here? And this is the first step which has to be done by you perfectly. Once it is done, then the entire problem is over. Right. Now the next thing is again simplify. That is 12 minus 8 gives you 4 and the rest of these things remains the same. Now you need to calculate del 1 and del 2. Right. What is mean by del? The determinant value of the resistances gives you del value. So once you take the determinant, you see 3 into 11 minus of minus 1 into minus 1. So 33 minus 1 gives you 32. Right. Now we are going to calculate del 1. How to calculate your del 1? To calculate del 1, you have to remove this column, okay, 3 minus 1. You have to remove this first column and this first column elements are replaced by these values, that is 4 and 8. Right? For calculating del 1, you have to change this first column. You have to replace this first column by these elements. That's it. So here 4, 8, minus 1 and 11 here. Again when you solve, the value of del 1 is 52. Right, that is 4 into 11 minus of 8 into minus 1. And again for del 2, now we have to replace this second column. Right, the first column remains as such and second column is replaced by the voltages. Right, again when you calculate, here the value is 28. Right, now we are going to calculate the values of I1 and I2. So I1 is given by del 1 by del. That gives an answer of 1.625 amps. And similarly, I2 is given by del 2 by del. That gives an answer of 0.875 amps. Right. So, Again we have to look back at the problem. So here current delivered by the batteries we need to calculate, right? So this is your first battery. So current delivered by this battery is simply I1, right? Because I1 flows in this way. So current delivered by the battery A is I1, whereas the current delivered by the battery B, here you see through this battery we are having I1 as well as I2. Now again look back at the direction. So here I1 flows in this way and I2 flows in this way, that is opposite to each other. Therefore, the current delivered by this battery 8 volt is given by, we have to subtract the values I1 minus I2 or I2 minus I1, whatever may be the thing, right? But here the thing is, these two directions are opposite, right? These two current directions are opposite, therefore here we are subtracting the values. Therefore, so current in battery A is simply I1, so just write down the value, and current in battery B is, we are having two currents flowing through it. Therefore, since the direction is opposite, here we are subtracting, that is I1 minus I2, so that is given by 0.75 amps here, right? Then the next thing is, again you see current flowing through this 10 ohm is again I2, right? So you can directly write the values. And final thing is, determine the potential across the load, that is voltage across this load, right? We know the value of current flowing through this 10 ohm resistor. So what is the formula for voltage? It is given by I into R. So here the I is 0.875 and the respect to R is 10. Therefore 8.75 volt is the potential across the load of 10 ohms. Right. So method 1 gets over here. We will move to method 2. So now we are going to solve the same problem by another method. Right. So in this case, you see again the same diagram, right? And here I am assuming the current delivered by battery A as I1 and battery B as I2, right? And the current flowing through this outer path is I3, right? Now from this diagram, can you guess what is the value of I3? I3 is nothing but it is the summation of I1 and I2, right? So that is our first step. Then the next thing is, again I am telling here I had assumed this loop current as per my wish. Right, it's up to you. You can select the way you want. There is no restriction that for this problem we have to assume the direction of current like this. Right, so we will proceed here. So from this diagram it is clear that this I3 is nothing but I1 plus I2. Again this is Kirchoff's current law, right? The current flowing towards the node is equal to sum of current flowing away from the node. Here these two are the currents that flow towards the node D and I3 is the current that moves away from the node D. Right, that's it. Now the next thing is we are going to apply KVL for the loops. So here again we are having two loops, right? Loops are nothing but closed path. So this is one closed path and this is one closed path, right? So now consider this loop DACBD, that is DACBD. Right, now consider this loop. And here now we had assumed that the direction of current is like this, right? So Kirchoff's voltage law is nothing but sum of voltage drop equal to sum of voltage rise in a closed path, right? So here a current flowing through a resistor will produce a voltage drop, as we all know. So here you see through this 2 ohm resistor we are having, what is the value of current that flows? I1 is the current that flows through this branch, right? Therefore voltage drop across this 2 ohm resistor is 2I1, right? And next when you gradually proceed, the current flows from minus to plus, right? Sorry, not to consider as minus to plus. Here we have to assume this direction only. So again it's from minus to plus, therefore it is plus 12 volt, right? And again when you move down here it flows from plus to minus, therefore it is minus 8. And again the current flowing through this 1 ohm resistor is I2 here, right? And since the direction of this current is opposite to the direction of our assumed path, here we are including a minus sign, minus 1 into I2. Am I making sense here? I'll repeat. You see, that is, we are taking the current direction like this, right? So the voltage drop is here 2 into I1, because in this branch I1 is the current that flows, therefore 2 I1. And again the direction is from minus to plus, therefore plus 12 volt, right? This is what I had written here, 2 I1 plus 12. Again when you look at this part, it flows in opposite, right? That is from plus to minus, therefore here it is minus 8. And the thing is, the assumed current direction is opposite to that of the previous current direction what we have. Okay, therefore here it is minus 8 and here minus 1 into I2. Because here initially we have assumed the flow of current direction like this, but when considering the loop, we are considering the direction in opposite side. Therefore here we are including a minus sign, right? So now when you simplify, finally we are getting the expression as 2I1 minus I2 equal to minus 4. Name this expression as 1. And now look at the second loop. So the second loop is D, B, C and D. Okay, D, B, C. So here it is E and D here. So again you see this I2 and the assumed direction of current is opposite to each other here, right? So therefore again you see it flows from plus to minus. You have to assume only this direction when you consider the loop, right? So plus to minus, therefore minus 8. And again 1 into minus 1 into I2, because again the direction of current we assumed is opposite here, right? So 1 into I2, and again the same thing here, I3 flows in this way, but the assumed direction is opposite, therefore minus 10 into I3, right? You see, this is our assumed direction, but the actual direction of the current is like this. So they are opposite to each other. Therefore, here when you consider this direction, okay, this path of flow of current, plus 2 minus, therefore minus 8, and again minus 1 into the current flowing through this branch is I2. So minus 1 into I2, and again in this part current I3 is flowing like this, but here our assumed direction is opposite, therefore minus 10 into I3. Right, this is what I had written here. And I3 is nothing but, as we already defined, it is I1 plus I2. So just substitute it here. Right. So once you solve the expression, we are having an equation. Okay, this is equation number 2. Now you have to solve equation 1 and 2. So for solving the equation, I know you people are familiar with solving quadratic equations, right? Because this is a basic mathematics thing. So anyway, here you see we have to cancel either I1 or I2. Now I choose to cancel I1. Therefore, I am multiplying this expression number 1 with 5. Right, because since here we are having 10, I have to make this 2 as 10. Therefore, here I am multiplying by 5. The entire expression gets multiplied by 5 here. Therefore, you see 5 into 2, 10 I1 minus 5 I2 minus 20 here, and the second expression remains the same. So in this case what happens, I1 cancels each other, and here we can easily calculate the value of I2, right? Once I2 is known, just substitute the value of I2 in any of the expressions, either in 1 or in 2. Then we can easily calculate the I1, right? Here I had substituted in equation 1, and once when you solve, the value of I1 is calculated as minus 1.625 amps here, right? So here we have calculated the value of I1 and I2, right? So the current delivered by battery A is I1 and current delivered by battery B is I2, because these are all the values of current we had assumed initially, right? And the next thing is we have to calculate the potential across the load resistance, right? So here the voltage across 10 ohm is nothing but, you see the current flowing through this load of 10 ohm is I3, right? Therefore, voltage across this 10 ohm resistance is I3 into R. So I3 into R, I3 is nothing but I1 plus I2. We know I1, we know I2, so just substitute. Here these two currents are with opposite signs, therefore subtract, right? So that gives an answer of 0.875. So when 0.875 gets multiplied by 10, here the final answer is 8.75 volts. Right. Here comes the end of this problem. You can solve problem by using any one of the methods. Okay, choose the method which is comfortable to you. If you have any doubt, let me know in the comment section. Thank you.